first the correlation coefficient. It is your R value. So just know it's like represented by the letter R, and we'll talk about that in our calculator in just a second. It's the last page.
Oh, I know that one. Is this our homework?
That is also going to be your homework. Yeah, so your homework will be just to finish the packet, whatever we don't finish. So if there was like a page or two that we skipped, I think there's like 2 pages that we'll skip, that'll just be your homework. So your R is your correlation coefficient, and it's like how close your data is to your line of best fit. So like how how close your data is to your line of best fit. So like thinking about it in like science, right? If you're doing an experiment and you're collecting data, would this graph in the middle tell you really any relationship about like what's going on between the data? No, right? This one right here is going to represent a what type of correlation? Positive or negative? Negative. This one would represent positive. So your R value, the correlation coefficient, if it's negative, then that means it's going to be like representing kind of like a negative slope, a negative correlation. Positive, representing positive slope, positive correlation. So the closer you are to -1 and 1, the better your data represents that line of best fit. So remember, you always want to be close to -1 or 1 with your R value. You guys can do this part on your own, just kind of going through and representing what the R values might be. I'm just going to go through our regression step. So if you go to this example here, example 1, so this data for the number of assault crimes committed in one Midwestern town is below. So x equaling 0 is 1980. So one thing you always want to know when you're given like data, if they have that, you want to change kind of your x values, because our years are x values. So if 1980 is 0, what really is 1983? 3. Now this would be 4, 5, 6, 9, 10, 11, 12, 13, and 14. So thinking about make a scatter plot using your calculator. You guys can do that on your own. I have directions for it. I'm just going to really go over the more important stuff below. So we're going to first make our equation for our line of best fit. But before we do that, there's one super important thing we have to do in our calculator first. So our one super important thing in our calculator is going to be to what's called turn on our diagnostics, because that gives us our R value. So to turn on your diagnostics, we are going to hit the blue button in the top left corner, and then 0 for catalog. And you are going to scroll down until you see the word diagnostics.
Wait, you said catalog?
Second and then 0, you can see catalog.
Diagnostic on?
Correct. Hit diagnostic on and then hit enter. It is an alphabetical order, so luckily it's towards the beginning of the alphabet, but just far enough where it's annoying to scroll. So that's why if you do it one time, then you're good for the rest. So I hit diagnostics on, I hit enter, I should see done, yes, my diagnostics is on, so that's good. So now if you remember back from Algebra 1, making your line of best fit, you're going to go to your stat, and you're going to hit enter. If you are having any calculator issues, just wait. See if a neighbor can help you, and if not, then I can come around and help you at the end, but let me get through all of this first. So to clear out your data, if you have anything, if you're have a yellow one because you're kind of the first ones to use it. So normally I'm just like right here, I just hit the up arrow, hit the clear button, and then the down arrow to clear it. So up arrow, clear, down arrow, that clears your list. So you want them all clear. So the one I'm looking all clear, list 1, list 2.
If you reset your calculator in the beginning and you get it, will it reset all of that?
It'll have all of this clear, but your diagnostics will not be turned on.
So then you can go back.
So you have to go and always turn on your diagnostics. So let's enter our data. So in my list 1 is my X values, which is the year. So I have 3, 4, 5,
7,
No. 6 and then 9.
7, 6,
It's 9.
9, 10, 11, 12.
No, Charlie, don't go to your head. No, don't.
What's she doing, Audrey?
So you're just entering those X values that you were given in your data. So we had 3, 4, 5, 6, 9, 10, 11, 12, 13, 14. So remember our year 0 was 1980. So now in our list 2 is going to be our Y value, which is the amount of crime occurring. So we should have, each one should match up. So with 3, I should have 25. With 4, I should have 23, and so on and so forth. So it will not work if you forget a value. So always take a second after you're done to double check, make sure you entered everything. You can always have typos. Human error.
Did we? How do you get rid of any numbers? I have 15.
So from here, take a second, double check your numbers. Yep, looking good. So I have my list 1 and my list 2 entered, all my data. So to get my line of best fit, when you guys are doing this on your own, there's step-by-step directions on the back here, but I'm just visually showing you. So we'll only go through it one time, but if you forget a step when you're on your own, always check back there for reference. So list 1, list 2 is all good. So I'm going to go back to my stat button. And I want to calculate my line of best fit. So that I want to calculate something. So I'm right-click overing to calculate. And I want my line of best fit. Which one looks like the word line? Line reg, which stands for linear regression, which is what we want. Option number 4. Note I wanted in this option, AX plus B. What does AX plus B look like? MX plus B, that's slope-intercept form. So I'm going to hit enter for my linear regression. Option number 4. So when you're hovering over option number 4, just hit enter. Then you'll be on this screen right here. So remember, my X's were in list 1, my Y's are in list 2. That's good, that's good. Something else that you can do that's really helpful, here when it says store reg EQ, you can hit the green button, which is alpha, and then you hit the trace button. Oh, I guess my computer is frozen. Alright, so you hit alpha trace. This is annoying. Alpha trace, and then it should have Y1 appear, so you can just hit enter. So just do alpha trace right there, and then I'm upset. So alpha trace, and then enter right there, and then you should be on a, so then if you just hit down 1 to calculate, and then hit enter.
Oh yeah.
So then you should have something nice come up where it says lin reg y equals ax plus b. A equals 1.3679. B equals 19.383. See how you have an R squared and then an R below? So R is what we were talking about. What did R stand for again?
Regression.
Your correlation coefficient, how close your data represents that line. So let's think. I have a 0.906. Do we think that's good? That is good, yeah. So that R number was, what was that, 0.906?
Yeah.
Let's just do 2 decimal places, so 0.91. So does the data represent a positive or negative or no correlation?
Positive.
Positive, good, it's positive.
Yeah.
No correlation would be something really close to what number?
0.
0, right. So what's my equation for the line of best fit? So think about you have y equals ax plus b. What was our a again to 2 decimal places?
1.37.
Can someone, just one person say it? 1.37. And what was our b to 2 decimal places? Just one person. Perfect. So think about writing that as a line of best fit. What would that look like? So think about your a. That's like your what value? Your slope. So that'll be y equals 1.37 x plus 0.38. So to predict the number of salts in 1995, think about what are you given here? Are you given an x or a y? You are given an x. What exactly is that x value that I would input here?
1990.
Yes, 15. Why?
Oh, because it's 19.
Because year 0 was 1980. So think about x is really 15 here. So instead of x, you're going to input 15 and then figure out what that is equaling to. And then try that same thing for those other two. So input 15 into your x. What did we find our output to be?
We go back to the...
So the SORBAG EQ is not a part of these parts here. I'll show it to you again when we get to another problem like it, like later on. So what is, when our input was 15, what was our output?
39.92.
39.92. Can I have 0.92 of an assault? Not really. So let's round it to a whole number. So as a whole number, it would be 40 assaults. Or, sorry, not a nice data to look at here. So why don't you guys try those last two? Ear and ear. Okay.
Oh, and then you just...
Yes.
Oh, okay.
So let's do this. You are gonna try E right now. And these last two, if you have a calculator and want to try it at home with the back of these instructions. If not, when you get here, there's 10 minutes before class starts. You can work on those during those 10 minutes, and I can help you guys with it too if you need help with it. So think about also if it's remember here we were given an x value and we just plugged it in. If you were given a y value, how would that be different? What would you do if you were given a y value? What if you're finding, listen up really quickly. I know we're towards the end of class, but one last important thing. If you were given a y value, so let's say instead if you were predicting the year that 50 assaults occurred, how would that probably be different? Yes, I would substitute it for the y and I would have to solve for x. That's it.